So this section we're going to be in section 11.4, we're going to be talking about tree diagrams. So to kind of get started with the slides. So we entered a cafe and offers a lunch special consisting of a main course, a beverage, and a dessert. The choices of meat is going to be corned beef, ham, and turkey. So we have three choices of meat. Beverage is either going to be soda, coffee, or tea. Dessert choices is going to be a brownie or a chocolate chip cookie. If a person purchases a lunch special and makes a selection at random, what is the probability of the customer selects a beef, coffee, and chocolate chip cookie? So basically what this instruction is, we're going to be making tree diagrams. We're going to be talking about the counting principle, determine the sample size, and then we'll get to this question as far as what the probability of this person selecting beef, coffee, and a chocolate chip cookie. Well, before we get to that problem, let's talk about counting principle. So if we're looking for any kind of a sample space, we're going to be multiplying the two outcomes together. So the first outcome for this particular one is going to be the coin being flipped. So M represents the coin. How many sides are on the coin? There's two. There's heads and there's tails. And then we're going to take the possible outcomes of a die. Remember, we've been talking about die in the other sections where there's six faces. So we have 1, 2, 3, 4, 5, 6. So if we flip the die, roll the die, and flip the coin, we're going to try to figure out the sample spaces for us getting at heads or number one, a heads and two, heads and three, and so forth, or tails and one and tails and two. So if we look at here, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We add them all together, we get 12. So how do we get 12? Well, what is 2 times 6? That gets our 12. So here is a example of another particular restaurant. So we have the same kind of choices of meat, beef, turkey, and ham. And then we have two side choices where we have macaroni salad and potato salad. And then we have choices of coffee and soda. So here's a coffee, here's a soda. Ooh, buttered soda. Have y'all any tasted of that? Yum yum. So these basic choices, she's trying to wonder what is the possibility of, what is the, as far as the counting principle, using the counting principle, what is the total amount of the sample space? So remember, three meats, two sides, and two beverages. We multiply it all together and we get 12. Now we're going to construct a tree diagram and list the sample space. So we know the sample space is going to be 12. This is how we go on here. So we're going to actually construct the whole diagram to see those 12 choices. So roast beef, ham and turkey, macaroni salad, potato salad, coffee, and soda. So for this first choice, the person can select beef, macaroni salad, and soda. That's one. And then we have beef, potato salad, and soda for, I'm sorry, coffee for this one. And then this is soda here. So we have beef, macaroni, and coffee, beef, macaroni, and soda. So that's 1, 2. So we actually go down. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So how do we get those 12 again? This is it came from the choices of, again, beef, the meat, the sides, and the beverage. So if a customer randomly selects one of this lunch specials, determine the probability that a roast beef sandwich and a soda are selected. So you can either do it one or two ways. You can make your own tree diagram with just the items that's presented to you, or you can just look at your listing. You can make the whole listing for the whole problem and just look in the listing. So let's make our first selection, just a sample here. So our first choice is that we can do beef, macaroni salad, and soda. That's one. And we can do beef, potato salad, and soda. That's two. So for this one here, there's two out of the 12, two out of the 12 possibilities that the person will select a roast beef, a soda in this problem. So you can also look up for in the listings. So remember, all we're looking for is, because we don't really care about the sides, We're just making sure they select a roast beef sandwich and a soda. So looking at these listings here, which one has a roast beef and a soda? Here's roast beef, soda, and then again we have roast beef and soda. So there's two possible outcomes. So 2 out of 12 reduces down to 1/6 as far as the probability. So let's move over to my MathFlash Plus and just work a few problems from here. Let's start with number 4. So for this one here, we're going to be using the counting principle, but this one here we have two answers that we need to replace: replacement and without replacement. All that means is once I select something, I get to replace it and put it back into the pool or the stash that I'm pulling it from. If it says without replacement, that means when I pull it and I try it again, that one I pulled stays out. So for this particular one here, we're going to do the replacement first. So there are 45 ways a state can be selected from a group of 45 states. So the first one, 45, times the next one, 45, gives us 2025. That's with the replacement. Now, if I actually take one out without replacement, that's going to leave us with 44, correct? So first I start off with 45, but now I choose one or select the second one. Remember, it's going to be one less because I'm not doing it. I'm doing without replacement. That means I'm not putting it back into the pool. So 45 times 44 gives us 1,980. So this one here is with replacement and this one without replacement. But again, the counting principle is when we multiply both of the outcomes together to get our answer. Let's move to number 6. Now these problems can be very lengthy, as you can see how many things you have to do with the problem, but I'm just kind of walk you through. This one doesn't have ones. Let's go to number 12. Yeah, so there's actually a lot of parts, A through E, so let's do each part. Let's start with A. So A says determine the number of points in the sample space. Remember, sample space we'll be using that counting principle. That's when we multiply M and then N together. But this case here, we have actually 3 things that we need to multiply together. So 2 times 2 times 2. So here are all my 2's. We multiply those together, we get 8. So the answer for part A, when we have sample space, is going to be 8. There's going to be 8 possible choices: vegetable soda, candy, vegetable soda, brownies, meatball soda. So you're actually going to do it 8 times. So part B is where we're going to have to select a factor tree. And I think they have icons where you can actually look at them and see how the layout as far as what it's supposed to be like. So for part B, you can just abbreviate it by putting vegetables for V, and then meatballs for M, and so forth. So here is my vegetables, soda, and candy. So vegetable, soda, candy. Then I have vegetable, soda, brownies, vegetable, soda, brownies, and then you just keep going with the whole the diagram tree. So your diagram again should look like this at the end. Start off with the first 2, branch it off, then branch this one off, then branch this one off, and keep branching them off until we get our letters like so. Part C is determine the probability that Steve selects a meatball for appetizer. So I guess I'm looking at this, looking at all our choices. I want all the number of choices that he at least can have meatball as a choice. So 1 or 2 ways again you can look at this. You can go to your listings in part B and list all the number of times you see an M. There's one choice. He can get these items, these items, these items, all these considered to have with meatballs. So how many are there? 1, 2, 3, 4. So the positive number of outcomes is going to be 4. Out of what? The total number of outcomes, remember, is going to be 8. Because 2 times 2 times 2 gives us 8. So if we reduce that, 4 over 8 reduces down to 1/2. So that's the probability of us having a meatball as our selection. Part D, determine the probability that Steve selects his fruit punch and cheesecake. So again, go to our listing and figure out where we see all F's and cheesecake. Oops, I guess they actually forgot one. So I'm going to say this one is going to be, we have a little error in it, but if this was candy or brownies, then you actually look for the C or the B along with the F. So for this one here, determine the probability that Steve selects a dessert other than brownies. So how many possible, um, how many of these sample points show Steve selecting a dessert that does not have brownies in it? So for this one here, we have 4. So let's go back up and see which one, all the ones that does not have brownies. So when you make out your here, remember, do not select the ones that have B's in it. So there's one that has a B. So 1, 2, 3, 4. So those 4 does not have involve a choice of brownies. So that's why we have 4 out of, again, 12. I'm sorry, 8. 8 could be the total possibility. So 4 out of 8 reduces down to 1/2. So that's going to be all for this section 4.